On page 115, topic 20, we'll be doing problem number 9, 12, 14a, 17, and 19. So here we have if y equals x minus 1, find all the values of x such that 3y squared minus 2y minus 4 equals 0. So what we really have to do here is find the values of y that make this equation true, and then we substitute, or we make that value of y equal to x minus 1 and solve for x. So it's just one additional step over previous ones that we've done like this. So first of all, we start with the equation 3y squared minus 2y minus 4 equals 0, and we look for acceptable solutions. We use the quadratic here. A is 3, B is minus 2, and C is minus 4. So minus B becomes minus 2, plus or minus this here. B squared is 2 squared 4, minus 4. A is 3, and C is minus 4. So when we add these or multiply these terms together, excuse me, minus 4 times minus 4 is 16. 16 times 3 is 48, so we get the 48. The 2a, of course, is 2 times 3. So we have 2 plus or minus 4 plus 48 within the square root of sign, which becomes 52 over 2 times 3, which is 6. So instead of 52, we can realize that 52 is 4 times 13. 4 times 13, we take the root 4 out, we get 2, and the 13 stays within the root sign. So now we can take out a 2 from the top and the bottom, cancel a 2 out, or divide 2 into 6, and we get 1 over 3, or 2 into 2 divided by 6, again, gives us 1 here implied, 3. So we get 1 plus or minus root 13 over 3. And from this, we should be able to get, if we know that y equals x minus 1, then x equals y plus 1. And so we get the y value, which is right here. This is the y value. We put that in right here. This is the x, this is the y, and we add 1. And so what we can do, instead of this 1, we can write 3 over 3, so that we get a common denominator. We add this 3 to the 1, and we get 4 plus or minus root 13 over 3. Now, the solution that we're going to check is the y1. We're going to put the y1 back into the 3y squared minus 2y minus 4 equals 0. So that's what we got for y. Disregard this little square here. Don't worry about it. It's not important. And so on the left side, we have 3y squared. We have replaced the y with 1 plus root 13 over 3 minus 2y minus 2. Here's the y right here. And this minus 4 is this. So we're looking at the left side of this equation. And when we work this out, we're going to, the first times the first gives us 1. The root 13 times the root 13, which would be the last, gives us 13. And the inner term is root 13. The outer term is root 13. When we add them together, we get 2 root 13. This is a perfect square right here. Now, what happens here is this 3 squared here becomes 9, but when we multiply it by 3, we get 3 over 9, which is 3. So this part here will have 3 over it. This part originally has 3 over it, and here we have minus 4. So this is just 1 plus root 13 squared, and then we multiply this term alone through by 3, and we got this completely. So now we're going to combine this under a common denominator. Instead of this minus 4, we're going to write minus 12 over 3. So we're going to combine all these 3 terms. We get 1 plus 2 root 13, which is this, 13, which is this, minus 2 is this term over here, and minus 2 times plus root 13 is minus 2 root 13, and this is minus 12. So what happens is you have 1 plus 13 is 14, 14 minus 2 is 12, and 12 minus 12 is 0. Here we have plus 2 root 13, here we have minus 2 root 13, so that sums to 0. So everything sums to 0, and the right side of the equation is 0, so the left side equals the right side. Now, this part, when we use 1 minus root 13 over here, the only thing that changes is this plus here becomes a minus right here. I'll move this down a little bit. This plus becomes a minus, and this minus becomes a plus. Everything else stays the same. So you get same, you can do this on your own, but we get the same thing that we got for the 1 plus root 13 over 3. And again, the left side equals the right side. So essentially what we've done is solve this equation for y. And once we know that, we can just transpose and say x is equal to y plus 1. So we can just add 1 to the solution, which we did right down here. So although this is the actual solution, we checked this value for y here, both values, and made sure they were correct. Number 12, find r in the compound interest formula a equals p plus bracket 1 plus r squared. If we've got to find the value of r if we're given a and we're given p. So first thing we do is take the formula. Okay, we know that a is 475 and p is 250, and we have to solve for r. So the first thing we do is take this equation right here, and we divide both sides by p, in which case we get a over p, which is this side, and here p 1 plus r squared divided by p. The p's will cancel, and I'll just be left with 1 plus r squared, because I want the unknown to be on the left hand side, and r is the unknown. We have to find r. So if I take the square root of this side, I get this. If I take the square root of this side, I get plus or minus the square root of a over p. So what I'm doing in going from here, this line to this line, is taking the square root of both sides. Now I transpose the 1, becomes minus 1, plus or minus the square root of a over p. And a is 475, p is 250. When you work that out, comes to be 1.9, and the square root of 1.9 is approximately 1.38. And we only take the positive value here because the rate cannot, or r cannot, be a negative solution. We're talking about dollars here, so this is really an interest rate. And so the only possibility is to take minus 1 plus 1.38, which gives us 0.38. So, two ways to check this. We check A equals P1 plus R squared. We put R equal to 0.38. We multiply the principal amount, this is really the principal, by 1.38 squared, and we get 476. So that makes sense. If R was not 0.38, we would not get 476. Remember, we are given A essentially is the amount that we get if we invest a principal amount at a certain rate. So, the other way to do it is to check the formula. We got R is equal to minus 1 plus square root of A over P. Take the right side of the formula, right over here, this is the right side, and we substitute the value of R in there. So here's the right side of the formula. This P is this P, this one is this one, and instead of R we've written this term here, so we put it in here. So the 1's and the 1 minus 1 cancels to 0. We get the square root of A over P, and we square it, so we get A over P. The P's cancel, and we're left with A. So the left side is A, and well, the right side comes out to be A. The left side is also A. If you go back over here, the left side is also A. So we find that the left side equals the right side. So you have two ways of doing it that you can check, and you could choose either one, but if you were checking that your answer was right, you should do one of these two. Here we're given a triangle, and this is the altitude here. How do I know that? Because that is the 90-degree angle. This little square indicates this. So this is the base, and this is the height. And the area of a triangle is 1/2 times the base times the height. So what's the base? The base is x, so 1/2 of the base, x. And the height, we're told, is 1/3 x, which is the same as x over 3. And that area is given right here, 30 meters squared. So really what we have to do is solve for x. Excuse me. And so 2 times 3 gives me 6. X times x gives me x squared. If I multiply this by 6 and this by 6, I get x squared equals 180. So x equals the square root of 180. 36 times 5, which equals 6 times 5, because the square root of 36 is 6 on the, if I take that out of the root sign, this is 6 squared. Take it out, I get 6. Square root of 5. 6 times approximately 2.236 is the square root of 5. I get approximately 13.42 as the value of x. Now I can check the area. The area is x squared over 6, 13.42 over 6, and this works out approximately to 180. 180 over 6 is approximately 30. Or, for a more exact solution, if I take 6 root 5, which is this answer, very exact, because we haven't, there are no approximations here. Let's see what we get. 6 root 5 squared. So 6 squared times 5 is 36 times 5, which is 180. 180 over 6 gives you 30. In this problem, we're told to find the dimension of a rectangle whose perimeter is 100 and whose area is 220. So let the length equal y, let the width, let the length equal x and the width equal y. What do we know? And the perimeter of this triangle will be twice the length plus twice the width, and that will equal 100 because I'm given that here, so I know what the perimeter is. The perimeter is twice the length, twice the width. And from this I can solve for y, transpose the 2x to the right side, get 100 minus 2x, and then divide through by 2, and y equals 100 minus 2x over 2. Now the other equation that I know is that the area equals the length times the width, which is xy equals 220, because I'm told the area is 220 and the length times the width gives me 220. So now I substitute 100 minus 2x over 2, which I got over here, into xy equals 220. The x stays the same, so this stays the same. And instead of y, I'm going to write 100 minus 2x over 2 here. So this is x. So what I've done here is to get everything in terms of one variable. This doesn't really help me because I got two variables. There's no way I can solve this equation. So what I do is I get everything in terms of one variable. I've got x, and then I interpret, or I get y in terms of x, which I got right here from the perimeter. So now what I'm going to do is multiply through by 2, and if I multiply through by 2, I get x, 100 minus 2x right here. Multiply this by 2, I get 440. So I'm just removing the 2 here. I multiply this by 2, and I multiply this by 2. And that gets rid of the fraction on the denominator. So now I have 440, and I have, if I bring the 100x onto this side, I get minus 100x. And if I bring the minus 2x squared to this side, I get plus 2x squared. So I'm just making this equal to 0. And I've got the 440 on the right. Bring the 100x from the left to the right. It becomes minus 100x. Bring the minus 2x squared from the left to the right. I get plus 2x squared equals 0. So now I divide through by 2. Each term by 2, and I get this just to make it simpler. Divide both sides by 2. Now I'm going to factor this. I can't factor this, so I'm going to use the quadratic. Minus b is minus 50, plus or minus 50 squared, minus 4a. A is the coefficient of x squared, which is 1. And c is 220. This is 2a, and a is 1, so this is 2. So here, minus 50 squared gives me 2,500. Minus 4 times 220 is minus 880. And when I say calculate 2,500 minus 880, I get 1620. So the square root of 1620 is 4025. So I have two possible solutions. I have the square root of 1620 is 1425. So I have 50 plus 4025 over 2, which is 90.25 over 2. And I have 50 minus 40.25, which is 9.75 over 2. So the two solutions, this divided by 2 gives me 45.13, and this divided by 2 gives me 4.88. So if x equals 45.13, then y must equal 220 over 45.13, what I'm doing is I'm going back into this equation. Okay, once I know what x is, I can then solve for y, and that's what I'm doing here. Go back down here. Y is 220 over x, and x, we came out with this. And the other solution is y equals 220 over the 4.88, which comes out to be 45.13. So the x here becomes the y here, and the y here becomes the x here. And so really what we have is, doesn't matter what you call x and y, but you multiply 45.13 by 2, and then you multiply 2 times 488 to get the perimeter, and this comes out to be approximately 200. And in this particular case, the x times the y, 45.12 times the 4.88 equals 220. Now I'm just looking at this here, and what have we done wrong here? Let's go back into the original equation, and of course, yes, I see the mistake. The mistake is right here. Okay, excuse me, I made one mistake here. This should be 100, not 220, and that's why I was a little confused on that. Okay, let's go over that again. So the perimeter is 2x plus 2y, right? 2 times 45 is about 90. 2 times 4.88 is about 9 plus. So 90 plus 9 plus gives me roughly 100. I had the wrong number here. And the area is x times y, 45.12 times 4.88 equals 220. So the last problem on this page tells us the height in feet of a baseball t seconds after being hit is given by the formula h equals minus 16t squared plus 6t plus 5. When will the baseball hit the ground? Well, here the key thing to realize, a baseball hits the ground when h equals 0. So what we need to do is set this equal to 0 and solve for the values of t, because t is the time. So we make h equal to the quadratic equals 0. A is minus 16, B is 76, and C is 5. We substitute that into this formula right here. And minus B is minus 76 plus or minus B squared is 76 squared minus 4. A is minus 16 and C is 5. So 76 squared plus 4 times 16 times 5 comes out to be 6096. And the A, of course, is minus 16, so that'll be minus 32. Now, this part you can do on your calculator. Comes out to 6096. So when I do the square root of 6096, it's about 78.08. Time can only be a positive solution. So the only number that will really work here is if I put a minus here. I get minus 154.08 over minus 32. You see, if I take a positive solution right here, make this positive, then the time will be negative, and time can't be negative. So I take the minus 7808. When I sum these two, I get minus over a minus, and I get 4.81. If I took the positive solution, I would get a negative value of time. So So this works out to be 4.81. You can see roughly minus 76 minus 78. You can understand that's minus 54. 32 goes into minus 54. And the minus become a plus, and it's 4.18 seconds. So if I substitute to check this value, 4.18, into the original equation, I get minus 16 times 4.81 squared plus 76 times 4.81 plus 5. So this whole term works out to be minus 370. This times this works out to be 365.6 and the 5. So if you add these two together, you can see that these two nearly cancel each other out, approximately equal to 0. Obviously, this is an approximate answer, and because this is approximate here, this is not an exact answer. Square root of 6,096 is an irrational number. So what we've done here is shown that for this problem, the ball will attain a height of 0, which means hits the ground when t equals 4.81 seconds. And that completes our discussion of the problems that we're going to do on page 115.